Let's talk about how to construct a confidence interval for a population proportion. So we can construct a confidence interval for a proportion using similar steps as the calculation for a confidence interval for a mean. Really, the only thing that's going to be different is that the proportions will always use a z-score, so the normal distribution, and then also the margin of error will be a little bit different formula. We also need to check the requirements for the proportion. So let's go over the steps on how to construct the confidence interval for the population proportion. Step 1 will be to find the sample size and the sample proportion. So our sample size here will be n, and our sample proportion is going to be p hat. Now to find p hat, can be a little bit tricky, but you just look at the proportion in question. So you have x over your sample size will usually be p hat. So those are the first two things you need to do. The next step is to verify the conditions are met for sample proportions. So the two conditions that we have here should look somewhat familiar. We're going to have n times p times 1 minus p has to be greater than or equal to 10, meaning our sample size has to be large enough. And since we don't know the population proportion, for p, we will just use p hat here because we are trying to estimate the population based off of a sample, so p hat is okay to use here. The next condition that we do have to verify is that our sample is not too large so that it doesn't lose its independence. So here we have n is less than or equal to 5% of our total population. Now, if you have your sample but you don't know your total population, then you usually can assume that this is true. Now, if both of these conditions are met, then we can continue on and find the rest of the steps for the confidence interval. Okay, the next step is pretty straightforward. You're going to find the z-value for the given confidence level. And just a quick reminder here, if I have, for example, a 95% confidence level, that would be 0.95 area of the confidence. Outside of the confidence level helps us calculate our margin of error. So this would be alpha over 2, which is 0.05 divided by 2, so 0.025. And then we just find the z-score that relates to 0.25, which would be equal to 1.96. Now you'll start using the z confidence scores so much that you'll probably start to know which ones go with which confidence level. The fourth step will be to calculate the margin of error. So the margin of error here is a little bit different than the margin of error when we had a mean. It's still the z-score, and then we're going to multiply it by the square root of p hat, so the sample proportion, times 1 minus the sample proportion divided by the square root of n, which is our sample size. So we just need to calculate that margin of error, and then you should know what happens after you calculate the margin of error. It would be to construct the interval. So the interval then would be our sample proportion minus our margin of error, then our sample proportion plus our margin of error. Now, after we construct our interval, the last thing we need to do is interpret this. So when we go to interpret this, step 6, we just say, we are 95% confident that the true population proportion, P, is in the interval. And that percentage is going to change based off of whatever your confidence level is. So let's take a look at one example of this. So let's assume we want to find the proportion of 2,000 students at a particular high school that like cookie dough ice cream. So we're just trying to figure out of the population, what percent do like the ice cream. So we're going to take a sample of 80 students and ask if they like cookie dough ice cream. 56 of those students said yes. Let's construct a 95% confidence interval to estimate the true population of students who like the cookie dough ice cream. So step 1 here is to find our population size, which is 80, so we know that, and our population proportion, which is p hat. So to find the population proportion, it's the number that actually like the cookie dough ice cream over the total sample size. So if you calculate that out, our p hat would be 0.70. So 70%. Now, after we calculate our sample size and our sample proportion, we need to check the conditions. So, step 2 would be to check the conditions. So, we need to figure out n times p times 1 minus p. We need to make sure that is greater than 10. And we also need to make sure our sample is less than 5% of our population. So, here let's try this n, which would be 80. Remember, we can use the proportion of our sample on this. So we go 80 times 0.7 times 1 minus 0.7. And if you go and calculate that out, we get 16.8 is greater than or equal to 10. So my first condition checks out. Now let's try the second condition. So our 80 has to be less than our 5% of our population. We know that our population is 2,000 because in the original problem it tells us. If we don't know our original population, then we can really just skip this. So if we calculate this out, it's 80 is less than 100. So that condition also checks out. Step 3 is to figure out what our confidence level is. So it's 95%. And we need to find the z-score that goes with the 95% confidence level here. So if that's 95% in the region, then my alpha is 0.025. And the z-score that goes with that alpha over 2 will equal 1.96. So our z-score that we'll need to use is a z-score of 1.96. Alright, so step 4 is calculating the margin of error. So remember, the margin of error formula is equal to z times our alpha over 2 times the square root of p hat times 1 minus p hat over our n. So if we go and calculate that, our margin of error is going to be the z-score that we found, 1.96, times the square root of 0.7 times 1 minus 0.7 divided by 80. And I'm just going to plug this into my calculator and I get my margin of error to be 0.10. So we have our margin of error now. So step 5 will be to calculate or construct our confidence interval. So remember, our confidence interval is p hat minus our margin of error and p hat plus our margin of error. So that means our sample proportion minus our E is less than our population proportion, which is less than our sample proportion plus E. So we just need to go here. 0.7, which is our sample proportion, minus 0.1 is less than our population proportion, 0.7 plus 0.1, which is saying that our population proportion is between 0.6 and 0.8, or our sample proportion is between 60% and 80%. So let's go ahead and do the last step, which is just interpreting this. So our final conclusion would be that we are 95% confident that the true population proportion of students that like the cookie dough ice cream is between 60% and 80%. So that is the steps on how you construct a confidence interval that involves a population proportion.